Hello and welcome to today's session of Algebra for Adults. I'm Mr. Harris and we're going to be talking about linear equations in one variable today. One variable means just one letter. So let's take a look at an example. Over here we have 2x plus 3 is equal to 8. This is an example of a linear equation with one variable. There's no squares or anything like that. So if we can solve this equation, and we come up with x is equal to 5 over 2. So let's look at solving typical linear equations. Over here, we have 3x minus 1 is equal to 2, and we want to know what x is. What value for x makes this a true statement? So first I'm going to get rid of the minus 1, and then I'm going to get rid of the 3. To get rid of minus 1, I'm going to add 1 to both sides. So minus 1 plus 1, that's going to give me 0, so that drops out. 2 plus 1, that's going to give me a 3. So my next line is going to be 3x is equal to 3. And finally, we're going to get rid of the 3 by dividing both sides by 3. And you end up with x is equal to 1. That's our answer or solution, or sometimes called the root of the equation. Next, we're going to take a look at some examples of equations in more challenging forms where you have to isolate the variable, isolate the x. So here's our equation, 3 parentheses x minus 6 equals 6 times x minus x. So first we're going to distribute and collect like terms, right? Now we're going to add or subtract something to both sides. And then finally we're going to multiply or divide on both sides by the same number. And in this case here we end up with negative 9 is equal to x. And since they're equal, we can just flip it over, have the x on the left, and we have x is equal to negative 9. So this is a typical type of question, and the steps that we followed are the following. We simplify the expression on each side, collect all the variable terms on one side and all the constant terms on the other side. We then isolate the variable and solve. We can check our proposed solution in the original equation. So now here's a little more challenging equation. So first thing we're going to do is simplify the algebraic expression on each side. So after I write down the problem on a sheet of paper, I'm then going to use the distributive law to over here with the 2 and the negative 3. That's going to give me this right here, 2x minus 6 minus 17 equals what we have here. Then I'm going to combine like terms on both sides if possible. And then I'm going to go to step 2, and where I'm going to collect variable terms on one side and the numbers, the constant terms, on the other side. So that means x on the left, numbers on the right. So I'm going to add 3x to both sides to get rid of it from the right side. And now I'm going to get rid of minus 23 by adding 23 to both sides. That's going to leave me with 5x is equal to 30. And now I can isolate the variable by dividing both sides by 5 right here. And I end up with x is equal to 6. That's my answer. It's totally simplified. Okay, now you can go back and check if you like. You would just put in the numbers in the equation for x and do the math. Okay, and you should come out in this problem with negative 11 is equal to negative 11. The fact that this is a true statement tells me that I did it right. Okay, so now we're going to talk about the different types of equations. You might have seen this in another way. There's an identity, that equation that's true for all numbers. There's a conditional equation. That's what we're mostly used to. It's true for at least one number. And finally, there's an inconsistent. That means an equation that has no real answer. So we're going to take a quick look at a question which asks you to reveal what you know about this topic. So which one is this? This one. First, we're going to solve the equation using our 4-step method. So we distribute, collect, and move to the other side, and you notice you're going to end up with minus 3 is equal to 5. And that's a false statement. So this equation is what we call inconsistent, when the answer does not make any sense. So I think that's the end of this presentation for today, folks. You have a great day.